Good morning, everyone. This is solving literal equations, also known as solving for quantities of interest or simply solving for equations where the answer is not a number. We'll start with some simple one-step exercises and progress to some more involved exercises. So let's take a look at we have several, right? We have 10 of them right here, but I'm just going to take a look at some of these. The first one tells me that ax equals 7. And I'm just going to read it like that. And my instructions are to solve for x. So I want to solve for x as if it had a number in front of this. So if this had 7x equals 7, we would all divide the 7. So this does not say 7x equals 7. It says ax equals 7, which means we're still going to carry out the same operation. So all this is testing is, do you know the relationship between the variables? Do you know the relationship between a and x? And most everybody could tell you that this is a times x. So in order to solve for x, I am going to need to use the inverse operation of division. All right, and I'm going to do that, and it's going to leave me with x equals 7 divided by a. And that's actually your answer right there. That's it. No need to find a numerical answer. Because 7 divided by a is in simplest terms. Let's look at another one. Looking at number 3, it says, so it gives you the formula E equals mc squared, which you might be familiar with. This is a little bit of Einstein action right here. So E equals mc squared, and we're solving for the variable m. Okay, solving for the variable m. So in this case, I need to see the relationship between m and c and the squared. So when I look at squared, the squared is only applying to c. So this can really be treated as one item, c squared. So this is really m times c squared, which means that, again, I can solve for m by dividing both sides by c squared. Final answer, E divided by c squared equals m. I could turn this right back into the original equation by multiplying c squared to both sides. So that's just inverse operations. We have some as simple as b minus 11 equals 3. This is the 7th example. In this case, if I'm solving for b, I'm going to add 11 to both sides. And b equals 14. Okay, now that one wasn't much of a literal equation. It was here we actually have a numerical answer. Okay, so what if we have some more advanced exercises? Let's get to the nitty-gritty right here. So here's an example. If I have h equals 5 dA quantity squared, or dA squared, not and then minus g. And my task is to solve for a. So I want to end up getting this a isolated, getting the a by itself. So I need to think, okay, this is 5 times d times a squared minus g. So I like to think of this working from outside in, or what is the variable or quantity most indirectly affected by a, right? And that would be g. So I can actually start this problem by adding g to both sides. Okay, if that's a little confusing as far as what to get rid of first, think of it like this. So if I look at my a, what is the first operation in order of operations that I apply to a? Well, it would be the squared, which means the squared needs to be the last thing to go. The next thing I would do after squaring is I would multiply by d, which means d needs to be the second to last thing to go. 5 needs to be the third to last thing to go. And the first thing to use inverse operations with has to be this g. So I'm going to add g to both sides. All right, now we're talking. So my result of h plus g, well, there is no simplified version. That's just h plus g. All right, equals 5d a squared. I'm going to divide both sides by 5d. All right, which, since 5 is being multiplied and d is being multiplied, I can divide them both at the same time. So I've got h plus g over 5d, and that equals a squared. My last thing is to take the square root of the whole thing, and I'm done because I'm out of time.